Hello, calculus students. Welcome to your last brand new lesson, and it's 8.1 L'Hopital's rule. We started this year with limits, and now we're going to end with limits. Just to give you a very brief background, Johann Bernoulli was the teacher, and hopefully if you've had French you can say his name, Guillaume de L'Hopital. He was the student, even though Bernoulli is the one who's given the credit for discovering L'Hopital's rule. L'Hopital was the one who published it in a book in 1696. Anyway, moving on. There's your little history lesson. Normally I do like kind of a proof and a discovery for this lesson, but we're just going to dig right in. Example 1. We have done this problem before at the very beginning of school. If you guys remember, your first step with limits, no matter what, no matter if it's L'Hopital's rule or Chapter 2 rule, you always plug in. So if I plug in here, I get 0 over 0, which is an indeterminate form. And we learned that that means do more work. So the do more work from Chapter 2 was factoring for this problem. You factor the numerator into x plus 2, x minus 2, all over x minus 2. And I cancel. My 0 over 0 problem is now gone. I plug in x is 2 right here, and I get 2 plus 2, and my limit is 4. That method can still be used for this unit. In fact, that's probably what I would do for this problem, but I want to show you that L'Hopital's rule is out there. L'Hopital's rule states if you get an indeterminate form, such as 0 over 0, there's also several other indeterminate forms, but for right now, 0 over 0 is indeterminate. We have no idea what 0 over 0 means. So I taught you guys to do more work. Well, now you could just apply L'Hopital's rule. For the AP exam, though, they have a very strict way that they want this work to be shown. Hopefully your college professors don't do this, but for this particular problem, you have to break apart and show that the numerator goes to 0. You also have to show, by breaking it apart, that the denominator also goes to 0, which gives you an indeterminate form. And you have to recognize you're going to apply L'Hopital's rule. My Calc 1 professor in college made us do this, but not this separating part. But let's be in good practice for the AP exam. Separate your numerator, separate your denominator, show that you get an indeterminate form. And once you have that, here's L'Hopital's rule. L'Hopital's rule says if you have an indeterminate form, then you go to the numerator and you just do the derivative of that, which is just 2x. The derivative of x squared minus 4 is just 2x. And then you do the derivative of the denominator, which is x minus 2. That derivative is just 1. Now you plug back in your little c value right here for x, and you get 2 times 2, which is 4. We said the limit from earlier was 4. Method 1, find the limit using factoring. Method 2, find the limit using L'Hopital's rule. So there's example 1. Feel free to pause the video at any time and rewatch. Here's example 2. So of course I'm going to do a trig function for you guys for example 2. Since I know you guys love your unit circle. So if I write down the limit as x approaches 0 of 1 minus cosine x all over x plus x squared. If I plug in, I get an indeterminate form. Cosine of 0 is 1, so I get 1 minus 1 is 0. Plug in 0 for the denominator, you get 0. However, that's not good enough for the AP exam. You have to show that you're going to break it apart. The numerator separately is a separate function that goes to 0. I could come over here to save room. X goes to 0 of the denominator. Sorry for the shadows. Also goes to 0. Therefore, I have 0 over 0, L'Hopital's rule. can be applied because that's an indeterminate form. L'Hopital's rule only works on limits. So now I'm going to do the derivative of the numerator. The derivative of 1 is 0, and the derivative of negative cosine is a positive sine of x. And then the derivative of my denominator is much easier with power rule. I get 1 plus 2x. Now I plug in 0 right here for x in both places. I could get another indeterminate form. If I do, I just repeat L'Hopital's rule again. So L'Hopital's rule can be repetitive. So if I plug in 0, sine of 0 is 0. Plug in 0 right here, I get 1. So my limit goes to 0. There's your first two examples. I'm going to stop this video and do a video 2 for you as well. Please watch both videos.